I want to thank you for being here at SQL Bits, especially on a Saturday. It's a weekend. It's actually looking kind of lovely in the UK, which I get doesn't happen that much. But let's get started. Good morning, everyone. Thank you so much for joining me. Thank you so much. This is the wrong deck, is it? No. Oh, wow. So I swear I'm a professional. This is not using lakehouse scale of data. This is star schema, all the things, but why? I forgot to adjust the title slide. Yes, sorry. Good start. Really good start. So my name is Benny de Jager. I work for Microsoft. I work in the Fabric CAT team. The CAT team is essentially the customer advisory team, and we help the product group within Microsoft make decisions based on customer feedback. Customer feedback, we also try to help customers by unblocking them, sometimes through escalations, sometimes to evangelizing stuff. That's put in short the things that we do. I help run a user group in Belgium called datamines.be. It's very similar to what SQL Bits does, to what various user groups do around the UK. We bring people together, we help them share their passion for data and enthusiasm so that they can learn, network, grow, all those things. If you want to find me afterwards, if you have questions, if you want to reach out, it's quite simple. If you're able to spell my name, you will find me. I always use the same thing, basically. I'm not a fan of pie charts, but luckily that is not the topic of today. It's also not direct lake mode. That's another session, I think 3 doors down the hallway. But what spurred the idea for the session? You know I'm wearing this t-shirt, star schema, all the things, which is cool. But why do we need to build star schemas? And spoiler alert, it was a random tweet on Twitter that turned into a very heated discussion, as is the usual case on Twitter, that spurred into discussions on, well, you always need to use star schemas. Flat tables suck. You never should use calculated columns, those kind of things, which was fine. I mean, in general, I do agree with a lot of those statements. The problem is just why? Why are those best practices? I'm a bit of a person that struggles with someone blindly telling me, you should always do me this, and doesn't give me a reason. So today, what I'm diving into is, let's take a few factors and let's take them head to head. Let's compare a flat table and a star schema, and let's use them for a few criteria. But most importantly, our imported Canadian in Belgium, called Kurt Bueller, he's written a fantastic blog post. It emphasizes on, well, we don't know what's going on. That person that created that flat table might not know better. Is it really our right to go slam that model without knowing any of the context? It focuses on empathy and making sure that we can help that person make better decisions in the future. And that's what spurred the idea for the session. I want to try to convince you that star schemas are a good thing, but I also want you to be able to say, well, I'm using a star schema because. That's the goal for today. So yes, okay, star schema, all the things, but be critical. If someone gives you a best practice, if someone tells you a best practice, why? That's the thought. And well, let's take a wonderful journey into my mind and my thought process. But it can get a bit wild. So let's go. I have data. I have data that is the New York City bikes, Jesus. The bikes. It means that it is a row for every single trip that has been taken since, I think, June 2013. Right now, the data that I have is roughly about 212 million. So not small data, not huge data, but enough to show you the actual differences between small and significant. But it's most importantly, as I said, I want to show you what the difference is between a star schema and a flat table. The fact that none of you is throwing stuff at me right now because of this atrocity, I find deeply disappointing, yes. But what's the data? They are flat files. Essentially, it is a CSV file per month. Per month since June 2013. Why? Well, because it's an open data set. That's the way I got the data. The data also changes over time, so it's got some of those pretty cool challenges that you need to deal with. But I turned that into 2 models. Into a flat file, so just a single table called trips, which has roughly, like I said, 212 million records. Now, I put that into a Fabric lakehouse but that's not the purpose of today. I could have just as well put that into an MS Access database, because I'm an idiot like that, or I could have put that into a SQL database, Oracle even. The data source itself does not really matter, because we're importing into Power BI. We're using import mode. So it's in a lakehouse, but don't worry too much about that. What I do want you to worry about is, well, we went from those 38 gigabytes to roughly 6.2 gigabytes stored in the actual data system, stored in the actual system where we're using that data. So that's the flat file. If I now go into the star schema, well, it's basically the same thing. It's gotten a bit bigger in the Delta file, but it's still those 212 million records. And then a bunch of dimensions under there. So actually, here, it's being made bigger, which I already have had as an argument, but yeah, it turns the data bigger into my data warehouse or into my lake. Yes, fair point, but we'll get there. So roughly put 6.2 gigabytes for a flat file, 6.6-ish if we add up all the things, we're at 7 gigs of data. So as I said, not massive, not small either, significant enough to show you the differences. So what's the architecture here? It's stored in AWS S3 buckets, and that contains all those CSV files. That's where those CSV files are, and then I'm using Fabric pipelines to get them loaded over into one lake. I'm turning that into a flat file, which is called an OBT model, one big table. Yes, it has an actual name of how you call it. An OBT model, but I had to cheat. I had to add a few columns to make it work. That I then turn into a proper Kimball star schema, and I use shared data sets, which are now called semantic models, and you will still catch me saying data sets way too often. Yes, they're shared semantic models. That's roughly put the architecture. So the difference is, what we're seeing is that the flat files, they are coming straight from the base model, which is the OBT model, and then the star schemas, they're coming from the curated layer. That's roughly put the architecture where I'm getting my data from. So nothing too fancy, but enough for me to show you what I actually mean. Now, what are the things that I'm going to compare it about? What are the things that I feel are relevant to have this discussion? One thing that matters for me in import mode is refresh time. I really, really care about the refresh time. How long does it take to refresh that data to be made available into Power BI import mode? What's the model size? How large is that model? The short version is, the smaller you can get the model, the better it will work with the engine, because the less data it has to scan, the faster it will be able to give you the results you're looking for. It's one of the aspects that's going to make stuff go vroom vroom. Then the usability and the reusability. How much do I have to cheat to get to the visualization that I need? And well, how easy is it to use that model? How easy is it to build another model without having to copy over all of the things that I need? And then, well, how complex does my DAX need to get? How well do I need to be able to write DAX? Spoiler alert, I do not write DAX very well. I have an option called Phone a Friend, which is called Phil CMark, and I love it. But I know that not everyone has that. Then, performance. Well, how fast does it go? But the costs. How much compute are you using? Because I do feel that we're still focusing too much on actual performance, how fast is it, and not enough on how much resources are you actually consuming, because that's what you're paying for. That's what you're paying for at the end of the day. And if you can get it in 2 seconds, or if you can get it in 3 seconds and half as expensive, what are you going to pick? Most of the people are going to say, give me option 2. So that's one. There is a 7th one, but I'm keeping that one for the end. Now, what are some of the tools that I'm using today? It's a list of the things I'm using. They're all hyperlinks below that, so if you have the slides, you can get those, but those are the tools that I'm using today. So, what are the models? As I said, as I've shown you, they are nothing too fancy. They are basically, and I don't want the report, I want the actual model. Yeah. I'm going to show you the 2 models but they are essentially the same thing that I've shown you before in the screenshot. It is one flat table with a few things where I had to cheat, and then a star schema. Yeah, should have opened those before. All right. So what this is, come on. What this is a simple one table. I've not done that much in there except changing a few data types, adding a few categories, and then adding a few fields because I otherwise would not have been able to show you the results. So one big table. Now if I show you the other one, if I show you the actual star schema, that is going to be one fact table with a load of dimensions underneath there. Now, the spoiler I can give you about the flat file is, well, I was missing a date table or a calendar table. Call it whatever you want. So I had to use AutoDateTime, or, well, add a date table myself, but I went with AutoDateTime to be able to use those results. And that's actually going to have quite of a big impact. So, as I said, simple star schema, one fact table, a lot of dimensions around it. So clean, pristine, ready to go, ready to use. Now, I didn't say no shortcuts, but I did cheat a little bit. My colleague, Matthew Roach, he's the guy with the purple hair, lots of swords, who's also in the CAT team, has a maxim called Roach's maxim of data transformation, and it says data should be transformed as far upstream as possible, as far downstream as necessary. What that means is, I've done a previous session where I've done everything inside of inside of Power BI Desktop. Inside of a Power BI Desktop where I went from, let's go from the single base table, let's change some data types, let's kill AutoDateTime, let's get rid of some of the columns, let's use a star schema, let's add a calculated column, which you can clearly see for model size and performance, it was actually good. The downside was, in Power BI Desktop, the refresh time kept growing and growing and growing and growing because I was doing everything in Power Query. And for 200 million records, well, it was getting a bit dicey. So it didn't scale as well as I saw fit, so I moved all of it into pipelines, into a lakehouse. As I said, could be a SQL database, could be something else, doesn't really matter today. It also meant that when I was trying to refresh that model, I was getting timeouts, it didn't scale as well, my capacity was getting throttled, so I had some issues. I could get it to work if I put in a lot more time. But then at the end of the day, I figured, well, I want people to follow Roach's maxim, so I'm going to take a shortcut and go to the next step. But it did not scale very well. So now let's actually go compare. What am I talking about? Well, refresh time. How do we measure that refresh time? Well, the simple thing that you could do is you could take your stopwatch, look at it, and stare at it for 10 minutes. But I'm assuming that most of you have something else to do. So my colleague Phil Seamark, he's a New Zealand guy that's also here, he's got a blog post which is something that's called Visualize Your Refresh. That is a Power BI file. You can just download that, and you can use it to analyze how long your refresh has taken for a specific table or a specific partition of said table. So what that means is you want to set up a profiler trace. The simplest way that you can do it is I have Profiler. If you want to open it through Management Studio, it's Tools and Profiler. There you go. Now, what you need to do then is I want to open a new trace. The gotcha is if you've not connected for the first time, you need to go into Options, and you need to browse for the actual model you want to find. Otherwise, you're going to get a timeout, and it's not going to work as well. If you've not authenticated before, you need to fill in your credentials so you can connect to the Power BI data set that you have in the service. You could do the same thing for your Power BI desktop file, for your PBIX file, or PBIX if you're a savage. That you can also do. So I'm going to connect to the star schema file for 2020. Yes, I'm going to connect to that, and now I need to make some decisions on when I've connected on what I actually want to do. So you want to make sure that you switch over to blank and then select only a few specific events. You want the job graph, the description of what it's doing. The blog post for Phil describes all of these steps so you can read through them at your own pace. I want the progress report end, so the status updates of when something has actually been done. That's going to give me insights in how it's processing my partitions, my segments, all of these things. I run that trace, and now if I would run a refresh, I'm just going to refresh a very small partition. That's not going to, well, I am. I am going to run a very small partition. There we go. So that's now executing. It's refreshing a single partition, and I should, maybe have, did I? No, I ran it on the wrong database. All right, so let's assume that was right. What I need to do is I need to save this as an XML file, trace XML, store that somewhere, and then go over to Phil's little tool. Now, I did the preparation work on these. So I have files ready to go for analyzing my refresh. I have these ready to go. So this is my first comparison between the two. It's for a single year of data, for only 2020. Flat file versus star schema. All right, so the star schema, come on. All right, so the flat file refreshes in 22 minutes for a single year of data. That's roughly 20 million records. I could get it to go faster, but this is just refresh now. It's burning 1 million of CPU time. 1 million, okay. Do you think it's gonna be more or less for a star schema? Less, all right, indeed. So it is roughly 530,000 of CPU time and 11 minutes of research time for a single year. So that's already a big difference. So it means it is using less compute and refreshing faster for a star schema, which is weird because I'm using more tables and I'm actually refreshing more data if you look at it that way. But it's not the case. It actually goes faster because we allowed a Vertipack engine, what's running under the covers of Power BI, to do its work more efficiently. Now, I also did a comparison for the big models. I did a comparison for the big models, and the same thing happened. But I ran into a problem because the flat file basically was not able to be refreshed through refresh now in the UI because I went over the budget that I had for a P1. So the 25 gigabytes of memory that I have for my data set, semantic model, that one, I went over it. So I was not able to refresh. So I had to cheat. Again, what I did was I increased it to a P2. So yes, okay, it stayed in the memory grant, but now it timed out because it didn't refresh in time. So a full refresh I was not able to do in 5 hours, which is an issue for a single table. The full refresh for the star schema I was able to do in like an hour and 10 minutes. But to keep it on the same playing grounds, I set up incremental refresh for both of them. So incremental refresh for the both of them. But the summary for refresh is it's faster to refresh a star schema, and it's less compute with a star schema. But that is, I'm not using any powered query transformations. Everything is done in my lakehouse or whatever you have. So it's just a simple connect to that table, use that table, nothing else. That's it. In that case, it's a clear win for a star schema. But there is also something called an attribute hierarchy that not that many people are aware of. And it's valid for a reason, because it's something that stems from the multidimensional days. It's what you needed to be able to work in Excel in a pivot table. Now, I don't care about pivot tables at this point for this model. I don't want them. It does add a lot of size and refresh time because it needs to build out that hierarchy. So what I can do is I can go into either the model or into tabular editor and look for a property called isAvailable in MDX. when I disable that, it's going to kill off that attribute hierarchy, it's going to make the refresh faster, and it's going to use less model size. So I did that for both of them. But that is, the results you've seen was already with that property set for where it should be. You can do that safely for columns that are hidden or not visible, columns that are not used in a sort by. So let's say you have a month name and you've got a month number and the month number is used to sort the month name, then both of them cannot be disabled. Or, well, if you've defined an actual hierarchy, then you also need them. So that can be a big boost, a really, really big boost. The ones that you can usually do this for with ease are the dimension keys, the keys you use to create the relationships. There's some blog posts, there's some links in there where there's more details, but it can actually be a big shift, a big difference in speeding up that refresh time. But please do not blindly do this for your entire model. You will run into issues. Now, model size. How big is the thing? I said 6.2 and 7 gigabytes for the flat file and for the actual star schema. So if I compare the two of them, that means that the flat file for a single year of data goes to 2.7 gigabytes. That is through the Vertipack analyzer. So for a single year of data, 2.07. For a single year of a star schema, it's 300 megabytes. Wow, that is a big difference. Now, what is the big difference between the two of them? I'll show you after I've shown you the actual difference between the big ones. Because for the full data set, 18.5. The flat table was 6.2 in my lakehouse. What is happening? I thought Power BI was good at compressing data. It is, but not with flat files. That's the thing. There are a few things in there that we'll go in through. For the actual star schema, well, that is let's say 3.1. So 38 gigabytes to 7 gigabytes in my lakehouse to 3.1 gigabytes in my actual flat file, in my star schema. So pretty good. What that means is that I can actually expect the engine to be able to do its work more efficiently on the smaller model. But what I've done is, I prepared this already, is I have a file ready to go on, no, this is not the right one. I ran a Vertipack analyzer in DAX Studio. If you want to run it, you make sure you connect to your model, you go to advanced, and you say, I want to view my metrics. But I've saved this instance before, so now I can go look into the details. That's the 18.5 we've seen before, but if we look into some of the details, well, that's the auto date time that I mentioned. So every single date time field that I have in my model is going to create a calculated table for every single date time field that I have. If I look at the actual table, well, there's a few things that are really killing me here. The biggest one is time. That is actually taken up roughly 75% of my model. So 75% is the date time field that I have in there. It means it's the actual size of the data, but this thing here, the two of them, are really, really big. It's the hierarchy that I'm not using. It's the hierarchy that is only used for Excel or some of the other properties, and then the dictionary. The dictionary is one of the processes for Power BI that it used to speed up getting to the right data, getting to the right results. But because of the fact that it thrives on having lower cardinality of records, this is actually a very bad thing. Because if I have date and time, I'm going to have a lot of distinct values. So typically the thing that we say is just take them apart. If you don't need time, just toss out time, because it's also going to be making a big difference. But then the one I want to stress on, the one I want to emphasize on is, well, for a station I have latitude and longitude. So let's say I want to look at start station latitude. Well, it's got roughly 522,000 bytes, 81 million for a dictionary, and 13 million for hierarchy size. Keep that in mind. Think about it. If I jump into the other one, I'm going into the dimension table, which is basically the dimension table of every single station that I have with the information that I need. Well, now what's the difference between the two of them? I can't remember if I took latitude or longitude, but let's go with it. It means that now I have less unique values, the size is significantly smaller, and the same thing happens for the dictionary in the hierarchy. Why? Because I only need to store that once instead of 117 million times. So the star schema is helping me reduce the size, gain some performance boost. So for me, I'm going to call this a clear win. I am going to call this a clear win because the size is a lot smaller, and we'll get to performance part, it's really going to help us there. Now, the one attention point that I do have is, what am I now using as a key to build my relationships? This is where some very heated discussions can start. I'm using a surrogate identity, basically. Sorry, Luke, I know I'm going to trigger you now. I'm using an identity field, a surrogate key. Why am I not using a GUID, a globally unique identifier? Because they compress very poorly. It's a 32-character bit string value that really doesn't compress well. It's not going to help me. Why am I not using the actual business key? Well, business keys change. Those relationships, they actually need to be materialized. They need to be stored somewhere. The smaller we can store that, the better the engine can do its job. So small identity, small integer values are really going to help me with that one. And we want to fit as much as we can into memory so that stuff can go vroom, basically. But the business keys can change over time. An employee, if I leave, if I come back, do I still have the same employee number? Yes or no? I see people going yes, I see people going no. So that's where these things can start. So I just want a value that is nothing to do with the actual business, but I create an integer, a surrogate key on top of that. So the one thing here that I also want to call out is something called the large model storage format. And it used to be one of the very big differences between Azure Analysis Services and Power BI, up until 2021 somewhere. We have something that's called a segment, and a segment is a chunk of data. It means that that's the way that we're physically going to group data and store it as a chunk of data for the engine to process it. Now, if I only need 2020, the 20 million records, and I don't need the other 190 million records, well, what do you prefer if I need to throw them away, chunks of 1 million at a time or chunks of 8 million at a time? What do you think is going to be more efficient? So having that larger segment size, the default segment size, is really going to help me, but it's also going to make the model significantly smaller. You can change that in the web UI, but you will not be able to download a PBIX file, period. Big, big gotcha. But it can help you if you have larger models. Now, what about reusability? How usable is that actual model? Well, which of the columns do I use? The star schema has lots of columns. It's still doable. It has about 27 columns. Now imagine if I'm coming from my beloved ERP called SAP, where I have 420 columns in a single table. What am I going to use? Typically, it's 10 columns and the other 410 don't matter, but what am I going to use? You have to scroll through endless columns to get there. If I turn that into a star schema, it's going to be more logically grouped, and I can find the actual data that I need. But as I said, well, the single table wouldn't allow me to do some simple analysis over dates and times without having a date table. So I needed auto-date time or an actual date table that I created myself. I went the easy route, I went with auto-date time. But I still am not able to do the time analysis that I was doing for my star schema. So I actually do need to create a timetable for that, a date table for that. And, well, I'm using some simple measures to determine how long was a trip. It's a start time, it's a stop time. What's the difference between the two of them? Those kind of simple things. So I needed to find solutions for that. So in the end, I went back to that base model, to the single flat file, and I added those columns there. Because if I would have done that in Power Query or in calculated columns, it would have not worked anymore, or as well. It would have led to a bigger model, to slower results, etc. So I needed to do, well, some workarounds, essentially. Now, any logic that I'm going to add to that single model is going to be harder to reuse. Because what if one of you comes in tomorrow and you want to reuse some of those fields? Well, do you go with composite models? Do you start recreating the logic? It's going to be a bit more difficult. So remember Roach's maxim. Data should be transformed as far upstream as possible, as far downstream as necessary. And, well, it's also the space where we're going to discuss about a topic where we could discuss something called implicit and explicit measures. Implicit measures means if I just drag a field called duration onto my canvas, it's going to suggest me something. Most of the time it's sum. I've seen max, I've seen min, I've seen average, I've seen distinct, I've seen all of the things. Power BI is going to help me with a recommendation for it. Whereas if I use an explicit measure, if I actually have a measure defined, I just say, I want the sum of the durations. I know what I'm getting into. Now, there are some other issues. Excel, the desktop client, still doesn't work with implicit measures. So if you want your precious business users to use pivot tables, you need to have explicit measures. So that usability part really comes back in this one. Now, let's go into the performance and the DAX complexity part. How does this thing actually work? Well, I have a simple report. I have a very simple report. I'm not a designer, please don't kill me. It is a few base things. It's a measure, count rows, it's the sum of the duration, it's the average of the duration, a breakdown of start stations with a count rows, a breakdown of stop stations, of end stations with a count rows, a breakdown of count rows over every hour, over all of the time, and then a breakdown per month, and then a map. Please plot me all of the stations that I've had. So nothing too complex here. Now, still have 19 minutes, right? Yeah, right, good. Now, if I actually open up the reports for 2020 versus flat file, let's look at a few things. This is where I'm going to use that tool I refer to as Performance Analyzer. Performance Analyzer is going to give me an overview of what is happening on my canvas. Everything that needs to be shown on the canvas, and a breakdown of how much time did I need for DAX, how much time did I need to render, how much time did I spend waiting on other things. We're going to compare the two of them. Now, let's look at the flat file. Flat file for just 2020. I'm going to start Performance Analyzer, and I'm going to go into my report. That report is, okay, it's actually fairly good now. It is 3 seconds. Whoops. So the slowest thing, the map, took about 3 seconds. I'm actually quite okay with this. 3 seconds, I think, is reasonable. So it's not that bad with a flat file. I like this. It's 3 seconds. Yes. Okay. Now let's go look at the same model in that star schema. Remember, it's just the data for 2020. So I've started Performance Analyzer. Now I'm going to go in there, and we'll see what happens. Exactly the same time. Whoa. I thought I mentioned that it was going to be faster. Is it? It's not always going to be faster. There's basically a variance in there that you're going to see, but it is roughly, for the amount of data that I have here, you're always going to see the same duration. It's going to be equally as fast for the report I have here. But remember when I said that performance isn't just about speed, it's also about costs? Let's look into a few things here. So I want to focus on the graph called throughout time. As I said, it's just a simple count rows over the months. So for 2020, what were the trips in every single month? What I'm going to do here is I'm going to get the DAX query. So this is for my star schema. The DAX query took about 106 milliseconds. The majority of the time, it's spent waiting on something else. It's spent waiting on other visuals to be done. I'm going to use this, and I'm going to copy that DAX query. I'm going to copy that DAX query, and I am going to go to DAX Studio, connect. Yep, thank you. Connecting to my model. Now I really need to rotate passwords. All right, go. There we go. What I'm going to do is I'm going to look at something called server timings. Server timings are going to give me a breakdown of the engine and how much time it spent on a few things. How much time did I spend in the formula engine? How much time did I actually use to get the data that is loaded into memory and do the transformations, the calculations? Storage engine means how much time did I take to get the data from my model and make it ready in smaller chunks for that formula engine. Now, clear the cache so that we can get the worst performance we possibly can, and let's execute this. Let's run that, and I should see, all right, so this is what I have. The query is executing in 33 milliseconds, and roughly put, I'm using about 188 milliseconds of CPU time. So it is fairly good. It's giving me the overview of what I had on the graph, but basically shown into a matrix. Now, if I go into that same Power BI report and I go throughout time, well, there's already a difference here, because this is now using half a second for the same thing. If I go back into DAX Studio, and this is not the right one, if I go back into DAX Studio and I paste that in here, I connect to the right model, there we go, and I execute the same query, what's it now doing? Yeah, this isn't right. I think it's not executing. All right, so this is why you have screenshots. So the spoiler alert there is that it's taking a longer time to give you, it's taken about roughly 8 times of CPU power to do that one query. Flats file versus a star schema. So yes, okay, the report may seem equally fast, but is it using the same amount of compute power? No. It's using a lot more compute power with the flat file to be able to do that. So in the majority of the results, what you're seeing is, well, for the star schema, and the flat file, for 20 million records, they're about the same. It's not that big of a difference. But do you think the difference is going to be the same when I flip it out to the entire model? Let's have a look. So the same report where I'm using the full data set. So all of the data, 213 million records. I'm going to do the exact same thing, and I'm going to make a comparison. What's happening here, do you think? Okay, well, the star schema didn't become that much slower. Roughly about half a second was added as a delay. So the data went 10x, but the performance was roughly the same. Now, if I look at the flat file, well, I start seeing some big numbers here. All of a sudden, I go up to 7, I go up to 5. Whoa! 200 seconds for the map visual. It took 200 seconds for the map visual to complete, and that was one of the faster runs. What I can tell you is that Power BI has, in the service, it's got a default timeout of 225 seconds. If a query goes longer than 225 seconds, we kill it. So I'm actually at risk of not being able to use my precious map because of the fact that I'm just using a default simple star schema. So it does have a big difference. So if I compare the two of them into that DAX Studio that I've done before, well, if I do the comparison for the map, it's not that complicated of a query. It is running for 1 second, and I'm using, let's say, 14,000 milliseconds of CPU time, which is significant. It is a lot, but a map, it is rendering a lot of data points. It is giving me a very broken down thing, so it's not that bad. But for the actual map, well, it's taken 181,000 seconds to just finish that query and 50,000 milliseconds of CPU time. So it's a lot more expensive just to render that simple map. So I hope that this is a clear difference for performance and the DAX But it does mean that it is just a simple thing. But the most important thing is, what I went over really quickly, is what is actually the difference between the two queries. I'll go back to the first queries that I used before. Yeah, I just want this to be gone, actually. Yep, I've seen it, thank you. Now, this is the query of the first one. It's basically saying, give me a summarized columns for the date, the month, the thing I'm using to use a sort by, and the actual measure. All right, then give me a top 1,000 and visualize that. So not that complicated of a query. If I need to look at the other one for the flat table, all right, okay, it's the same thing. It's using the fields from the local date time, but then I have this. It's doing a more complex statement for the same visual, where it's actually going to say, well, I need everything, but ignore the filters that you have. Because of that, well, I'm now running into something which is called sampling in a visual, where I can only visualize 3,500 data points on that single graph. So that leads me to believe that it's actually doing a lot more, and there's a big difference in those simple queries. So for a simple graph, where I want the month and account rows, you can already start to see there's a big difference in the complexities. There is a man with a puppet trying to distract me, sorry. It means that, yes, for that simple thing, yeah, I know I shouldn't have said that because now you're looking. It means that that is already getting more complex. Now, I want to do year-to-dates. I want to do time intelligence. Pretty simple if I have a star schema. There's functions. If you want to go the Italian method, you can use that. With a flat file, it's going to become a lot more complex. You have to do some more complex DAX to get that to work. And you will not be able to get it to work equally as fast. So quite of a big deal if you ask me. Now, for cost, I've roughly covered that before in the majority of the other things, but the refresh time, it actually exceeded my P1. So if I wanted to use that model without incremental refresh, I needed a P2. That's ×2 already just for the capacity. For CPU consumption, I'm consistently seeing higher numbers for a flat file or an OBT model during the refresh time, during reporting, or when I'm just writing random queries against that model. So I'm burning a lot more compute with a simple model. This is not yet anything complex. So there are some clear differences coming out of this one already. Now, if I bring this into a big overview, I think for a session that's titled Star Schema All the Things, this should not be a big surprise. I'm seeing consistent, shit. I'm seeing consistent numbers for star schemas. Yeah, that's what you get when you're doing late night edits. I'm seeing consistent numbers, some consistent better results on the star schemas for all of these things. So I think you should be convinced right now. But there's a seventh one. And it's actually a big one. Do you care about your results being correct? Yeah, I see some heads going, yeah, that's kind of important. Yeah. Well, there is something, I'm not going to go into too much detail here, there is something called auto-exists. It's a property that the engine uses when you're using multiple filters on a single table when you're using the summarize columns DAX function. When you're using the summarize columns DAX function. What that means is it's going to try to merge together those two filters, and it's going to drop some records on either sides that you would actually need. So usually what that means is you'll get less records returned. Why it does that? Well, it does that so it doesn't have to scan the entire data set multiple times. It's going to help you get better and faster results. Well, faster results, not better. You can disable it if you want to, but in all fairness, you should just make a star schema. There are some really good examples and really good videos from the Italians on SQL BI. The link is in that one below. Especially if you have 40 minutes to spare, look at the video. They're going into some really good explanations. But it means that if you have multiple filters on one table, if you have a flat table, that's the case, you're probably going to get wrong results. And I think that's kind of a big one to compare the two of them together. Now, what about a galaxy? That's 6 minutes, right, Richard? 5, okay. What about a galaxy? What about multiple fact tables? If you want to call it a galaxy or a constellation, I really don't care. Call it a multi-fact model for all I care. But it means that, well, if you're going to try build relationships, fact-to-fact relationships, yeah, those are not going to work well. It's the same thing that I mentioned before, where a relationship needs to be materialized. And you'll notice there's a big dip in performance when a relationship goes over somewhere between 2 to 5 million records, depending on the actual model. So if it's two big tables you're trying to merge together to a relationship, it's not going to work as fast. So if you have multiple facts, well, typically you'll want to look for something called conformed dimensions. If I've got a fact sales and I've got a fact product, well, I've got a fact production or manufacturing orders, if I use the dimension called products, it's going to filter both of those fact tables. That's going to work a lot better than trying to build a relationship between the two of them, especially when it's many-to-many or bidirectional. They can lead to some funky stuff there as well. So, I do want to mention that star schema all the models. But I do want to make sure you understand the why. I've gone through 6 different factors, and I've added a 7th bonus one. After I cheated on the slides, it should be quite obvious that for this specific example, it was different. But does that mean that it automatically translates to your model? Well, I'm assuming so. I would be surprised if it's not. But does it hurt to verify that if later down the road you get challenged, does it hurt to verify if it's actually going to be better? Probably not. And if you know that that model is going to scale, if it's going to grow, well, it's probably better to do it right in the beginning rather than have to come back and refactor the entire thing in 2 years' time, because you will have forgotten what you've done. There are a bunch of resources in there. As I said, the QR code for the slides are here. I do want you to provide me feedback on the session. It's the first time that I've actually poured this into a session, so I do appreciate any feedback. So we have 3 minutes of time. I'll gladly take any questions you have right now. Yes, please. Is there a way to automate these checks? Some of the developers we have might not be as aware, and, well, we might run into some issues. The one that I've been doing before myself is you have best practice analyzer and tabular editor. You can run that through a DevOps pipeline. That helps. Now, the thing that is really exciting, sorry, I'm going to talk about Fabric, it's called Semantic Link. It's a Python library that you can use in notebooks, and my colleague Phil has been doing some pretty cool stuff. Essentially, what they're trying to do is they're trying to build in a lot of those checks into that notebook. You can execute that notebook, you can get those results, whatever you want to do with those results, alert it, you can do that. Yeah. Okay. Any other question? What is my take on Snowflake schemas? Oh. I'm sorry, we're at time. That's where it gets difficult, because of a lot of the things I said where I'm making the data even smaller, I'm adding more relationships, but the problem is mostly going to be is, well, how are you going to go back from the furthest flake, and how are you going to traverse back? Usually with Snowflake schemas, you're going to have to introduce many-to-manys to get it to work, or bidirectional filtering. And that can lead to some results. Typically, I try to stay clear of them unless I have no option. That's my view on Snowflake schemas. Yeah. Yes. How does this translate into direct query? Test it, but you'll see that a lot of the same principles go back directly through direct query. The difference is the model size aspect will be just what you're having on your database, but DAX complexity compute is going to be exactly the same. Refresh time also doesn't apply because you're not refreshing, but you'll see very significant differences for a star schema or a flat table in using direct query mode as well. Same thing for direct lake. We're at time. Thank you so much. If you have questions, I'll be around for like 20 minutes, and then I need to go. If you have other questions, reach out on the socials. You have them. Thank you so much. Enjoy bits.